anyone wants to find 11C8, then simply you can go for 11C3 because this concept. So 11C3 means 11 into 10 into 9 by factorial 3. See how many committees of 5 with a given chairperson can be seated from 12 persons. How many committee members of 5 with a given chairperson? Chairperson is compulsory. Chairperson is compulsory. And one of the person in this 12 will be fixed. That person is a chairperson. Then rest of the 4 you have to choose from the rest of the 11. So among these 12 persons, one chairperson is there. Everyone have to select the chairperson. Then, so we choose 4 from the rest of 11 only here. So how we can finish? The chairperson can be chosen in 12 ways. Four can be chosen from the remaining 11 members. That is 12 into 11C4. So if you simplify also, you get 12 into 11 into 10 into 9 into 8 by factorial 4. So 12 into 11 into 10 into 9 into 8 by 8 1 ja, 8 3 ja, 3 1 ja, 3 3 ja. 3 into 7 2 ja, 22. 3910 is 3910 ways. So combinations with repetitions. This is very important topic, Andy. The last topic and important topic. Suppose we wish to select the repetition a combination of smaller objects from a set of n distinct objects and distinct objects. Please remember this formula. The number of such selections is given by, so generally we are writing like this, and n plus r minus 1 comma r. This is some people or some of the authors, they can write like this. Some of the authors n plus r minus 1 comma r. So all these three represents are indirectly or directly representing combinations only. Indirectly or directly representing combinations only. See, example. In how many ways? In how many ways can we distribute in how many ways can we distribute 10 identical marbles among 6 distinct containers? So n is equal to 10, r is equal to 6. The number of C of 10 plus 6 minus 1 comma 6. Then C of 15 comma 6. That is we can distribute in how many ways we distribute 10 identical marbles among 6 distinct containers. N is equal to 6 and R is equal to 10. Please read this. So n distinct objects, a combination of R objects from a set of n distinct objects. N distinct, n is equal to 6. This is C of n plus R minus 1 comma R. C of 6 plus 10 minus 1 comma 10. Then C of 15 comma 10. Then 15C 10 is nothing but 15C 5. So calculator can give you this value. No need to find manually. See, C of n plus R minus 1 comma R represents, also represents the number of non-negative integer solutions of the equation xn is equal to r. Find the non-negative integer solutions of the equation x1 plus x2 plus so on xn is equal to r. See here, find number of non-negative integer solutions of the equation x1 plus x2 plus x3 plus x4 plus x5 is equal to 8. So if you observe your previous papers, every time you have this question, every time this model. So this is r is equal to 8, n is equal to 5. Then direct answer, number of non-negative C of n plus r minus 1 comma r. C of 5 plus 8 minus 1 comma 8. So C of 12 comma 8. Simple. But you remember that the total value is representing r. So very important model. Find the number of positive integer solutions of the equation x1 plus x2 plus x3 is equal to 17, where x1 is greater than or equal to 1, x2 is greater than or equal to 1, x3 is greater than or equal to 1. The constraint is there. x1, x2, x3 are the greater than or equal to 1. So what is given? x1 greater than or equal to 1, x2 greater than or equal to 1, x3 is greater than or equal to 1. See, let y1 is equal to x1 minus 1, y2 is equal to x2 minus 1, y3 is equal to x3 minus 1. Because then y1, y2, y3 are non-negative integers. So whatever the constraint is given, we supposed to convert into non-negative integers. That means what here? Y1 must be greater than or equal to 0. To get that, what happens here? Constraint y1 plus 1, y2 plus 1 plus y3 plus 1 is equal to 17. Then which implies y1 plus y2 plus y3 is equal to 14. Then it gives n is equal to 3, r is equal to 14. N equal to 3, r is equal to 14. The number of non-negative solutions C of n is 3 plus 14 minus 1 comma 14. 17 C of 16 comma 14. This is C of 16 comma 2 also. C of 16 comma 2 means what here? This kind of simple things you can calculate. 16 into 15 by factorial 2. 8. 15 8 ja 120. Similar way, find the number of integer solutions of that T where x1 is greater than or equal to 2, x2 is greater than or equal to 3, x3 is greater than or equal to 4, x4 is greater than or equal to 2, x6 is greater than or equal to 0. So please you continue attend this problem. How you get it here? Let y1 is equal to x1 minus 2, y2 is equal to x2 minus 3, y3 is equal to x3 minus 4, x4 minus 2, y5 is equal to x1. You continue this problem per side. Find the number of integer solutions of x1 plus x2 plus x3 is equal to 20 such that 2 is less than or equal to a different problem, different approach. 4 is less than or equal to x2 is less than or equal to 7, minus 2 is less than or equal to x3 is less than or equal to 9. The previous case only greater than or equal to conditions, but this time both are there. So how to solve this? Simply let you see on the left side. We are seeing only this side. y1 is equal to x1 minus 2, y2 is equal to x2 minus 4, y3 is equal to x3 plus 2. Since the reason is what here and from this one. Actually what? According to the previous case, these only I have mentioned in earlier case, x3 is greater than or equal to minus 2. Please see, here also same. When x1 is greater than or equal to, then only I consider y1 is equal to x1 minus 2, where y1 is greater than or equal to 0. Then modify the function. What happens here? Y1 plus 2 plus y2 plus 4 plus y3 minus 2 is equal 20. Then y1 plus y2 plus y3 is equal, it is 16. 16. Number of non-negative solution C of n is 3 plus 16 minus 1 comma 16. Then C of 18 comma 16. This is 18C16. This is 18C2. 18 into 17 by 2, 9. 170 means 153. You have the number is 153. So actually మన strength 25 కదండి.
31 sir class.
31. Okay. 18C16 or 18C2, that will be answer. This is okay for left side, but other side also upper bound is there. Lower, in earlier problem we have only lower bound, then we continued, but this time we have upper bound also. So for this occasion, this is I am considering total number of, then it may be presented as like this is 153.
Strength 31 sir.
31 sir. Okay.
16 plus 15. 31.
Sir, when x1 is less than or equal to 5. When x1 is less than or equal to 5. So coming to this side, x1 is less than or equal to 5. We have how much, sir? X1 is how much here? What is x1? X1 is nothing but how much here?
y1 plus 2.
y1 plus 2 less than or equal to 5. That is y1 is less than or equal to 3. When x2 is less than or equal to 7. Similarly, we have y2 plus 4 is less than or equal to 7. That is y1 is less, y2 also less than or equal to 3. When x3 is less than or equal to 9, we have y3 minus 2 is less than or equal to 9. That is y3 is less than or equal to 11. So I am constructing a set A1 like contains y1, y2, y3 belongs to S such that y1 is greater than 3. I am assuming actually y1 is less than or equal to 3. Against I am considering y1 greater than 3. A2 is y1, y2, y3 belongs to S such that y2 also greater than 3. Prime I am considering A3. y1, y2, y3 belongs to S such that y3 is greater than 11. So we have to find, this means number on net and A1 bar intersection A2 bar intersection A3 bar. So A1 is Y1 greater than 3. A1 bar means what here, Andy? Yes. A2 bar means what here? Your requirement, your existed condition only. But I am assuming against. So number of elements in A1 complement intersection, A2 complement intersection, A3 complement. Addition, conditions, mutually inclusion, exclusion conditions I am using. Let us consider, let new variable Z1 is equal to Y1 minus 4. Because only Y1 is greater than 3 now. Then I am considering what here? Y1 is greater than or equal to 4. So what I am considering, Y2 is greater than or equal to 4. Then Y3 is also greater than or equal to not 11 and 12, because integers now no other values will be there here. So let Z1 is equal to Y1 minus 4. Then Y1 greater than 3 in brackets, that is Y1 is greater than or equal to 4. Automatically what happens here corresponds, always I have to get like Z1 is greater than or equal to 0. Then you write in the equation here. You modify the equation. What is the equation? Y1 plus Y2 plus Y3 equals 16. Na? So I write Z1 plus 4 plus Y2 plus Y3 is equal to 16. Then Z1 plus Y2 plus Y3 is equal to 12. Number of solutions for which Y1 greater than 3 is C of, what is R and D? R is 12, N is 3, comma 12. That is 15 minus 1. C of 14, comma 12. Then that is 14 C2. 14 into 13 by 2. 91. Similarly, Z2 is equal to, I take Y2 minus 4. Then Y2 greater than 3, that is Y2 is greater than or equal to 4, corresponds to Z2 also greater than or equal to 0. So Y1 plus Z2 plus 4 plus Y3 is equal to 16. Y1 plus Z2 plus Y3 is equal to 12. From here also I can write, this is again 91. Similarly, Z3 is equal to Y3 minus 12. I think so. Y3 minus 12. Yeah, Y3 minus 12. Then Y2 greater than 11. Y3 greater than 11. That is Y3 is greater than or equal to 12. Corresponds to so Y1 plus Y2 plus Z3 plus 12 is equal to 16. Then Y1 plus Y2 plus Z3 is equal to 4. Then I am getting, this is C of 3 plus 4 minus 1 comma 4. 6 C4. That is 6 C2. that is 15. Next time, continuation. Next, let Z1 is equal to Y1 minus 4, Z2 is equal to Y2 minus 4, then Z1 greater than or equal to 0, Z2 greater than or equal to 0. Then what happens, Andy? Z1 plus 4, Z2 plus 4 plus Y3 is equal to 16. Z1 plus Z2 plus Y3 is equal to 16 minus 8, 8. So it will gives A1 intersection A2. A1 intersection A2 is 3 plus 8 minus 1 comma 8. So 11 minus 1. C of 10 comma 8. Then C of 10 comma 2. 10 comma 2 is 45. A1 intersection A2. The next, let Z2 is equal to Y2 minus 4. Z3 is equal to Y3 minus 12. Then Z2 comma Z3 greater than or equal to 0. Y1 plus Z2 plus 4 plus Z3 plus 12 is equal to 16. Y1 plus Z2 plus Z3 is equal to 0. Then A2 intersection A3 is equal to C of R. R is how much here? R is 0. N is 3. 3 plus 0 minus 1 comma 0. C of 2 comma 0. That is 1. Then let Z1 is equal to Y1 minus 4. Z3 is equal to Y3 minus 12. Then Z1, Z3 greater than or equal to 0. Same. Z1 plus 4 plus Y2 plus Z3 plus 12 is equal to 16. Z1 plus Y2 plus Z3 is equal to 0. Then A1 intersection A3 is equal to C of same 2 comma 0 is 1. See, Z1 is equal to Y1 minus 4, Z2 is equal to Y2 minus 4, Z3 is equal to Y3 minus 12. Here Z1, Z2, Z3 greater than or equal to 0. So 4 plus 4, 8, 8 plus 12, 16. It is not possible thing. The total will exceed more than 16. Then this will be 0. So finally, what I want to find, A1 bar union A2 bar union A3 bar is equal to this minus A1 union A2 union A3. Here S means universal set. That is 153 minus A1 plus A2 plus A3 minus A1 intersection A2 minus A2 intersection A3 minus A1 intersection A3 plus A1 intersection A2 intersection A3. So 153 minus, yeah, then the first one 91, second one 91, third one is 15, then this is 2, this is 2. That is, sorry, 1 and 1. minus 45 minus 1 plus 0. So this total will be 153 plus 47 minus 182, 192, 197. 190, 200 minus 197 is equal to 3 is the answer. Yeah. This is called principle of inclusion and exclusion. Number of arrangements by principles of inclusion and exclusion. This is the permutations and combinations. So you go through this problem. If you have any doubt, you ask me on the day also. Whenever I will come for internal examination, please you go through that. If you have, you ask me in personal also. Then how I am considering these all. So my condition is always at least y1 must be in the at least condition. y1 is greater than or equal to 4, y2 is greater than or equal to 4, y3 is greater than or equal to 12. So in earlier problems, in this problem and in this problem, only minimum condition is there. Maximum condition is not included. Whenever the maximum condition also includes, then the procedure is this. We can go find number of dearrangements by using either principle of inclusion and exclusion. But ultimately, I'm using only one formula here. x1 plus x2 plus so on, xn is equal to r. Total is r and number of things are n. Then you can find C of n plus r minus 1 comma r. So this is in the permutations and combinations. This is not there in the internal syllabus. Graph theory and this part won't be there in the internal syllabus. We have exam on Thursday, na? Next Thursday.
Yes, sir.
27th kadandi?
Avunu, sir.
Okay. But graph theory and this for only final examinations.
సరే నార్మల్ టేబుల్స్ అవి ఎగ్జామ్లో ఇస్తారా సార్?
సార్ నార్మల్ టేబుల్స్ తీసుకెళ్ళండి సార్.
అలాగే సార్.
తీసుకెళ్ళండి సార్ నార్మల్ టేబుల్స్. నార్మల్ టేబుల్స్ తీసుకెళ్ళండి సార్.
ఓకే సార్, ఓకే సార్.
ఇంకేదైనా టేబుల్ కనుక వచ్చి వాల్యూ కావాల్సి వస్తే సార్ మీరు మ్యానిపులేట్ చేయండి సార్. వాల్యూ మీకే మీరు వాల్యూ ఓన్ గా అజ్యూమ్ చేసేసుకోండి. నో ప్రాబ్లం.
ఓకే సార్, ఓకే సార్.
బట్ ఎట్లా కరెక్షన్ చేసేటప్పుడు నేనే కాబట్టి ఐ విల్ గో త్రూ ఇట్. ఇఫ్ క్వశ్చన్ పేపర్ తెలుస్తుంది కాబట్టి దెన్ ఇఫ్ వాల్యూస్ ఆర్ లేకుండా, ఎందుకంటే యాక్చువల్ గా అదర్ థింగ్స్ ఏం అడిగినా అవుట్ ఆఫ్ సిలబస్ అవుతుంది సార్, ఒక్క నార్మల్ కాకుండా. వీళ్ళు ఏమవుతుందంటే రెగ్యులర్ లో చెప్పే వాళ్ళకి సిలబస్ సరిగా ఐడియా లేక వాళ్ళు ఏదో చెప్పుకొని వాళ్ళ పేపర్ ఇస్తుర్రు. బట్ లాస్ట్ టైం వీ ఇన్ఫార్మ్డ్ దెమ్ క్లియర్లీ, దెన్ డోంట్ ఫాలో దట్. ఒకవేళ అలాంటిది ఏదైనా జరిగితే దెన్ విల్ గో త్రూ ఇట్.
ఓకే సార్.
If ఏదైనా అవుట్ ఆఫ్ సిలబస్ వస్తే ప్లీజ్ రైట్ ద క్వశ్చన్ నెంబర్ అండ్ యూ మెన్షన్ ఇట్, ఇట్ ఈస్ అవుట్ ఆఫ్ సిలబస్.
ఓకే సార్.
ఓకే సార్, గుడ్ నైట్.
ఓకే సార్, థ్యాంక్ యూ సార్, గుడ్ నైట్.
థ్యాంక్ యూ సార్.
ఓకే.
हेलो रवि कुमार गुरु
సార్.
सर, लास्ट में क्या बोला रवि कुमार सर?
హలో.
सर लास्ट में क्या बोला?
ये परम्यूटेशंस कॉम्बिनेशन यूनिट 4 का बोला सर.
अच्छा,
यूनिट 4 का नोट देते ना अभी.